Hello everyone and welcome to episode 28 of our Raspberry Pi series, and in today's episode we're going to be installing WireGuard on our Raspberry Pi. If you've been following along with our Raspberry Pi series, you will have many different Docker containers installed on your Raspberry Pi. Now these are only accessible from within your local area network, so they're not going to be accessible from outside of your network unless you've used Nginx Proxy Manager like we have done in WordPress and Nextcloud to specifically access that service. In this episode we are going to be looking at a VPN, which is a virtual private network, which creates a secure tunnel from outside of your network into your network. You basically have it on your device that's outside the network, and that device will act as if it's within your network. So WireGuard can be compared to OpenVPN, which is a similar technology. The good thing about WireGuard is it's more simplified in the sense of setting it up as well as the code. There is 4,000 lines of code for WireGuard. With OpenVPN, there is over 400,000 lines of code. So this makes the attack vector smaller for hackers to exploit the code. So WireGuard uses the latest encryption technologies. It uses CharChar20, Curve25519, Blake 2, SIP#24 and HKDF. So WireGuard has been in development since 2016, but it is a relatively new technology compared to OpenVPN. It was implemented into Linux kernel last year in 2020. The benefits of using WireGuard is that it's simple to use, it is fast and it's secure. So before we get started, I just want to thank those who have subscribed to our channel. If you haven't, please hit that subscribe button and the notification bell to be notified of any new uploads. If you guys want to support our channel, you can become a Patreon. There is a link in the description below. Currently, we only have one membership level. We will be adding more in due course. But what that will give you as a supporting member is a shout out at the end of every single episode. So keep an eye out for that. So we've got a lot to cover today. If you guys are ready, we're going to have a look at the network map and see how this all fits together. So first things first, we're going to look at a static IP address that you get from your ISP. So for layman's terms, we're going to be on our mobile phone and we're going to be outside of our connection. So our ISP, which could be any mobile phone provider, gives us a IP address for our mobile device. Okay, so say we wanted to connect into our router. So your mobile providing ISP will give you a IP address for your device. So you will have on your device a WireGuard application. So your WireGuard client here will be configured with the IP address of your router in your house. So in this scenario here, we are looking that your ISP is giving you a static IP address for your home or office network. Now this is quite common in the business markets, but in the home market, they tend to be dynamic. Because there is a shortage of IP version 4 IP addresses, these are not commonly given to home addresses. Okay, so what they do is they give you something called a dynamic IP address, which means that you lease the IP address from your ISP for a lease for amount of time. Now when that time lapses, they'll issue you with a new one, or if you have to reset your connection or for any reason like that, you'll be issued a brand new IP address. So in this scenario here that we're looking at, okay, this is a static IP address. So within the WireGuard application that you have on your phone, you will have pre-configured the IP address and the port number, okay, that you set here. So the IP address that will be set within the configuration file will be the IP address of your router, which is statically given by your ISP at home, okay, or in your office. So with that static IP address, it's quite simplified, this process. So with that being said, your WireGuard application will dial in, okay, it will hit your router here. So with this incoming request, your router will say, I know where this port is, 51820, it is being forwarded to your Raspberry Pi. So that will forward that packet on, okay? It will come down to the Raspberry Pi, and the Raspberry Pi will have your WireGuard server on there, which will then handshake with the client, and then it will allow you to have access to your local area network. So in the previous episode, we looked at installing MotionEye OS on a separate Raspberry Pi with a camera attached to that. So in this scenario, you are then on your LAN. You can then connect to that MotionEye camera, and you can see the feed from outside the network, which is really helpful. As I said before, the majority of people do not have a static IP. They have what's known as a dynamic IP that will issue you with a new IP address. So say we've reconnected now. There is our new IP address. Now you can see the problem now that's occurred. So if inside the configuration file on your WireGuard application on your mobile device is set, okay, to look for that IP address and that port, you can see quite clearly here, it's not going to get through because this IP address of your home or your office network has changed. So what we're going to do is we're going to set a workaround for this. We're going to use Nginx Proxy Manager to help, as well as Cloudflare. So in this workaround, this left side here is outside of your network, as well as this Cloudflare service here. So all this here is outside of your network. Everything this side here is within your network. So this is your LAN and this is the WAN, okay? Wide area network, local area network. In our WireGuard application on our mobile device, instead of setting an IP address, we are going to set a domain. So in this example, we're going to call this your domain. So this could be any domain name that you purchase and use. So within your configuration file, your domain and the port number 51820 is set. Okay, so what it's going to do is it's going to come out and it's going to look for this domain name and this port number. So this domain name is going to be managed by Cloudflare. So what's going to happen is the request is going to come out to Cloudflare. Cloudflare is going to say, I know where your domain is. It is equal to this IP address. It's going to bring it back down to your router. Okay, on your router, you're going to have this port configured to your Raspberry Pi, okay? And on your Raspberry Pi, you're going to have Nginx Proxy Manager installed. And Nginx Proxy Manager is going to pick up this request that comes through your router. It's then going to say, oh, I know where your domain is, okay? And this on this port number, it is equal to the Raspberry Pi's local IP address, which is 192.168.2.5 in this example, on port 51820. It's going to forward that packet to your WireGuard server, which is then going to handshake and authenticate with your client on your mobile device, and it's going to let you into your LAN. Okay, so it's from there you can then access everything on your local area network, including your Motion Eye camera. This will now enable you to view your camera feed from outside of your network. So the last step in this workaround is we're going to need a Docker container that works with Cloudflare to automatically update the IP address. Now I'm going to show you how this works. So in this example, our ISP is now giving us a new IP address. So what will happen is on our Raspberry Pi, we'll have a Docker container, which is a Cloudflare container, which will automatically keep monitoring the public facing IP address of our router. So once it notices it's changed, it will update within the Docker container. So it will then say your domain is equal to now your new IP address. So then what it will do is it will send this new entry up to Cloudflare, which will update your IP address with Cloudflare. And then Cloudflare will say your domain is now equal to the new IP address. This will all be done automatically, so you don't need to update this yourself. So Cloudflare will allow the domain name to go back to the connecting WireGuard user. To follow along with today's episode, I recommend that you have followed our Raspberry Pi series. This will explain how to install everything that you're going to need for today's episode. So the first thing you're going to need is a domain name. You can purchase one from Namescheap. There's a link in the description below. Then you're going to need to have that domain name managed by Cloudflare. So you're going to need to add that domain name to Cloudflare. Then you're going to need to have Nginx Proxy Manager to forward that port onto your Raspberry Pi so it knows where to direct the packets. So now you know what you need for today's episode. We're going to get straight on now and we're going to install a WireGuard Docker on a Raspberry Pi. So the WireGuard Docker container we are going to be using today is maintained by linuxserver.io. It's updated very frequently and it has over 10 million users that use this image. So if you scroll down the page further here, you'll see that it is compatible with our Raspberry Pi. So it's compatible with the ARM32 architecture, which is fantastic. They've even gone out of their way, these Linux server guys, to add a couple of environment variables in here, which will really simplify the installation setup of our server. So this Docker composed section here, we're going to use as a base. We're going to edit a few of these fields, and we're going to make sure that this is set up correctly to work with our Raspberry Pi. So we're going to head over to Cloudflare now, and we're going to log in. And we're just going to make sure that our domain is set up correctly to work. So here we are. I'm going to use my addicted2tech.net domain for this example today. We're going to go over to the DNS settings here. And we're going to make sure that DNS only is selected for the A entry and the alias, which is the star. Make sure both of them have DNS only written on it. So now that we've confirmed that our domain is managed by Cloudflare and we have turned DNS only on, we're going to come back to our Raspberry Pi series here. So we're going to scroll down the page till we see episode 8. We're going to click on that. Now, we've done all this top bit here. So we've got to keep scrolling down here until we find here, creating a Cloudflare API key. So what we're going to do now is we're going to create this API key. So we're going to go back to Cloudflare and then we're going to click on our profile up here and click My Profile. We're going to click API Tokens. And then we're going to click Create Token. And then right at the very bottom, you see Custom Token. We're going to click Get Started. And then we're going to call this a name. So it's a descriptive name, anything that you want. I'm going to call it WireGuard. And this next section here, we're going to set to Zone. And then we're going to set it to Zone. And we're going to, so this is Zone Settings. And then we're going to click on Read. and then add more zones. We're going to click on here again, and then zone again. This time it's going to be zone, and this is going to be read again. And then one more, we're going to click on that, and we're going to click zone, and we're going to have DNS, and we're going to have this one as edit. And then under zone resources, we're going to click on where it says include, we're going to click all zones, and we're going to change that to all zones from an account. So we're going to select the email account of our Cloudflare account. Now that's all you need to do in here. We're going to click continue to summary. We're going to click create token. So we're going to copy this token now, and you can put that into a text file. Okay. So now we're at step 5 on this same page. We're going to keep scrolling down, and this will show you how to add the Cloudflare Docker to our stack. So we're just going to copy this stack here, and we're going to paste that into our notepad. So remember, this is just for the Cloudflare container. So we're going to connect to our Portainer on our Raspberry Pi. On port 9000's Portainer. And we're going to log in. Okay, so now we're logged in. We're going to click on local. So now we're going to click on stacks. And we're going to click add stack. I'm going to name it Cloudflare, and I'm just going to put VPN. And then I'm going to take what we've got from here in our notes, and I'm going to cut it, and I'm going to place it in here. So now I'm going to edit these fields. So you guys are going to need to know what your PUID is and your PGID is. So to find that, you need to connect to your Raspberry Pi. On port 1984, because that's the one that we set during our Raspberry Pi series. Yours may differ. And I'm logging in with the user that we set up. Okay, so now we're logged in. We need to find out what the PUID and the PGID is of our user. So we're going to just go ID and then the username, which is user1. And you can see from here, it's 1001 is my UID and GUID is 100. So now we know what that is. We can just leave these two fields the way they are if yours is the same. Now where it says API key, we're going to need to change this field here. So we need to go back to our notepad here and get that API key that we got from Cloudflare, and we need to paste that in here. And there you go. Now under here where it says zone, okay, example.com, you need to put in the domain name of your Cloudflare, which we're going to use. In our example, it is addicted with a 2 tech.net. And leave proxied as true. So now that we have put all them fields in, we just need to scroll down the bottom, and then we're going to click on deploy the stack. Now if you go to containers, and if you come down the line here where it says Cloudflare VPN, that's what we set up, this is our container here. And if you look in the logs, you should see that it's updated successfully, and your domain name should now be pointing to your IP address. Now to check this, you can go back to Cloudflare, and you can click on your domain name again. And if you go to DNS, you should now see under your DNS the same IP address that should be inside your Docker container. So if we go back to our network map, you can see that we now have our domain name linked in Cloudflare, and we now have this Docker container connected to Cloudflare and updating the IP address. So that's what we've done so far. So the next step is to make sure that our Nginx proxy manager is configured with the correct IP address to link the domain name through to our WireGuard server, which we haven't installed yet, but we need to do this first. So when we go to install our WireGuard server, it will recognize that domain name and the IP address and set up the right settings within that application. So in this example here, we are using 51820. You can set this port to anything that you want. You just to make sure that wherever you change the port and any of these links, they need to be matching exactly the same. To set up Nginx Proxy Manager, you'll need to log into your dashboard from within your Raspberry Pi. Mine's on my IP address and it's on port 81. So I'm going to log in with my details. Okay, so now what we've got to do is we need to click on hosts, and we're going to add a host. So we click add proxy host. And then we're going to give our domain name that we've got at Cloudflare. Obviously you'd put your domain name in there, and now we're going to put our IP address in there of our Raspberry Pi. So the port number we're going to use is going to be in our Docker Compose stack here, which is port 51820. We're not going to install an SSL certificate or anything else, so that's all we need to put in here for now, and you click save. So this is going to save a HTTP only proxy, so that's what we want. So that's all you've got to do in Nginx Proxy Manager. So we return to Portainer, so we're now ready to install our WireGuard Docker container. So we're going to come down to stacks, and then we're going to click on add stack, and then we're going to call it WireGuard. So I'm going to copy and paste this from the linuxserver.io page that we were on before. And now we're going to edit some fields in here to make sure that it's correct. So we're going to come down the line from the top down to the bottom. So we're going to leave everything the same here. Under PUID, I showed you how to get that before. So we're going to delete that. I know that mine's 1001 and my PGID is 100. Set your time zone for TZ here, where it says TZ equals Europe London. That's where I am, Europe London. You guys set that to where you are in the world. Under server URL, so if you guys have a static IP from your ISP, what you can put in here is auto. What this will do is will automatically find your outfacing public IP address, and it will automatically add that to the server, so it knows how to find its way out. But as we said earlier, we are under a dynamic IP address which can change, so we need to make sure that we are using the domain name from Cloudflare that we are setting up. So mine is addicted2tech.net, and under server port it's 51820. We're going to leave that the way it is. So the guys at linuxserver.io have introduced this peers here. This is fantastic because what this does is it's incremental value. So the more you put up, the more peers you want to connect. So let's say I had 2 devices that I wanted to connect here. I'd put 2 peers. So once you run this stack, it will automatically create them user folders with their private and public keys, as well as the QR code that you can use on your mobile devices. So that is fantastic. Like, it's really good the way they've implemented that into the stack. So I'm going to set up 2 peers just to show you. So moving down the stack here, under peer DNS, it's set to auto. Again, the Linux server guys have installed a DNS server in with this container, so it automatically finds the correct DNS settings. I would leave that the way it is. These last 2 fields I'll leave the way it is, unless you specifically need to change the root for any reason. Under this volume section here, we need to create a path to our app data folder, which we're going to do now. I've moved across to a Linux system so that you guys can see the text properly when I'm putting it in. So we need to SSH now into our Raspberry Pi. So on Linux, this is how you do it. SSH, TAC-P for the port, which is 1984. And then we've got our username, which is user1, and then the Raspberry Pi IP address, which ours is that. Yours may differ. And now you need to put your password in. And we are now connected. So I'm going to clear that out. So now we need to navigate to our app data folder so that we can create that config folder. And it's on srv dev, and that's our drive name. Let's make this slightly bigger. And then into the app data folder, and we're going to clear this out. Now, as you can see, that's where all our apps are stored. So we're going to create a WireGuard directory here, so mkdir from make directory, and we're going to call it WireGuard. Okay, we got it there, and we're going to go into that WireGuard folder now. And we can just put the config file straight in there. So we're going to go pwd, which is print working directory. That will give us the full path to that folder, which we can then use in our stack. So we're going to copy that into memory, and we're going to minimize this now. So where it says here under path to app data folder, so anything that is left of this config is outside of the container. So that's going to be in our Raspberry Pi file directory. This is what we need to change. Anything on the right hand side of this config is the config folder. Okay, so that's within the container itself. And this last section here is the libmodules. This is linking to the host libmodules file, where it can use their modules to actually set up to make sure that the WireGuard server will work correctly. So where it says sysctls, we're going to take that out. Now that's for clients. We don't need that under the server environment. it wouldn't work under our environment anyway. If you try to deploy that, it will come up with an error. So if it does come up with an error, make sure that you delete that section there. So apart from that, we are all set up and ready to go. Just one more thing you may have noticed is that WireGuard uses UDP. It doesn't use TCP at all for its traffic. UDP is a lot faster than TCP. It hasn't got authentication in it. So just so you're aware that when you forward your port later on your router, that you're forwarding the UDP port. Now right down the bottom here, we've got deploy to stack. We're going to click on that now. Now if you go back to containers, now you should see that your WireGuard container is connected. And if you click on this logs here, well, at the bottom here, you should see this IP tables here that set up the correct IP tables for the packet forwarding that we need for this to work correctly. So the last thing you need to do is to make sure that you forward the port on your router down to your Raspberry Pi. This is very important so that Nginx Proxy Manager picks up that request and forwards it to the correct Docker container, which will be your WireGuard server. So we need to make sure that this is correct. So we're going to log into our router. So I'm using the ASUS RT-AC66U. Your router may be different to mine, but this is just giving you a simplified overview of how to forward the port. So we're going to put in here our admin user. Your credentials may differ depending on the manufacturer of your router. So once you are logged into your router, you need to go down to the left-hand side here, and somewhere you should have a menu that says WAN. If you click on WAN, and we go to the virtual server port forwarding. Then from here we can add the service name. So we can say that this is for WireGuard. So the source IP we will leave blank. And the port range will be our port that we want to forward, which is 51820. And then where it says local IP, you should put in your IP address of your Raspberry Pi. And then where it says local port, I would then just put in the same port again, 51820. And then under protocol, just put on UDP, because WireGuard uses UDP, and then click on the plus sign. And then once you've done that and you have it all set up like that, you need to click on apply. So any requests that now come in from port 51820 will come through your router. It'll come down to your Nginx Proxy Manager. So the Nginx Proxy Manager will forward that request onto the WireGuard server, and your client will be able to authenticate and handshake with your WireGuard server. So what we're going to do is we're going to navigate to the config folder so you can see all the WireGuard files and configuration folders. So as you can see, there is some files in here, and you can see that these two here, peer 1 and peer 2. So these two different files here are our peers. They can be used to configure your devices to connect. We're going to go into there now. We're going to peer 1. And we're going to add this out. Now you can see it's got the public and private keys here. And it has a peer1.png. Now this is the QR code. So if you're going to connect through your mobile device, you can set up you can basically show the QR code, and you can scan that and automatically connect to your device, which is fantastic. If you guys want to connect any other devices that doesn't have a camera on it and can't use a QR code, you will need to use this peer1.conf file. We're going to cap that out now so you can see it. So as you can see, it has the private key in there and the public key of peer 1. And this is all you're going to need to configure your devices. It shows you the domain name that we've set up and the port number here. So that has everything that you need to pass on to any device that you want to connect. So if we go back up the file structure here, the other file of interest here is the wgo.config folder here. Now this wgo.conf file, this contains your private and public keys of your server. I'll show you that now. So as you can see in here, it has the interface, it has the IP addresses and the ports that it's listening on. It has the private key of the server itself. Again, obviously this is quite sensitive. You don't want this information to be passed on to anyone else. It has all the IP tables and the routing that it needs, and then it's also got the public keys of the peer 1 and the peer 2. So what we want to do now is we want to look at the peers and to see if anyone's connected to it. We need to execute this command from within the container, so it won't work if I use the wg command here. So we need to execute a command within the Docker container. You need to use this command, docker exec WireGuard, because that's the name of our container, and then the command that we want to run, which is wg. Now, as you can see, it shows you the interfaces, and it shows you the listening ports, and it also shows you who's connected. Right now, because we haven't connected any devices, there is nothing connected in here. So we're going to have a look at that once we connect a device. So what we need now is a QR code that we can scan on our device. So to get that, we need to execute another command within that Docker container, which is this, docker exec tac it, and then we want the WireGuard docker, and then we want the /app/show tac peer, and then the peer number, which is 1. This is the one that we're in, and then press enter. And there is the QR code that you can scan into your phone or your mobile device, and that will automatically connect it. Okay, so now just to confirm that we are connected on our mobile device, we're going to clear this out. And now we're going to run this command, docker exe-it WireGuard, and then wg. And there you can see we have had a handshake. We connected 35 seconds ago. So we're now over on our Android device. We're going to install the WireGuard application. So to get all the details that you need to manually add, we can go back to our terminal, and we're going to clear this out. And then we're going to lsla. So the file that we need to use to configure is the peer1.conf file. So we're going to cat that out. And there is everything that we're going to need to connect to the server. So we've come back to our Android device, and we're going to click on plus. And we're going to click from create from scratch. I'm going to give this a name. So this is the interface details. So what we need to do is get the private key here. And we're going to copy and paste that into private key. And it'll generate a public key. That's fine. Just keep that the way it is. Under address, under here you've got to put the address as 10.13.13.2. That is what it says in our configuration file. And on port is 51820. And DNS service, we can set it to what it says in the configuration file, which is 10.13.13.1. Again, I'm just copying and pasting this directly from the configuration file. Under peer, again, underneath you go to peer, where it says peer, under that section there, you put the public key in. And then the endpoint is addicted to tech, or whatever domain name that you have. You just keep copying and pasting these fields in. And allowed IPs, just copy and paste that in as well. So all fields that are in that configuration folder you've put into here. So now you've added everything exactly the way it is in your peer.1conf file. Remember, there is an interface section and a peer section. Make sure you put them in the correct order. You click on save. The last thing I'm going to show you is how to add an additional peer to your WireGuard server. You need to come back to Portainer and click on stacks. Then you need to look down the line here for your WireGuard stack and then click on editor. And then all you need to do is incrementally add how many peers that you need. So if you had 2 peers and you want to add another 2 peers, you can now put 4. And then you press update this stack or update this stack. And now that that's done, if you go back to your server and we do go up 1 level here and you go ls here, you'll see that you now have 4 peers. Wow, so that was a lot to take in today. I hope you guys understand the concepts and how it all comes together. If you guys have any problems, please let me know in the comments below. So as you can see, WireGuard is a very useful application to use if you need to create a VPN solution. It's open source, it is private, and it's also secure and it's fast. If you got benefit out of our content today and you enjoyed it, please hit that like button as well as the subscribe and notification bell to be notified of any new content that we upload. In the description box below, we have provided some Amazon links that we have confirmed is working perfectly with our Raspberry Pi series. All of these components we've tried and tested. Again, they are Amazon affiliate links and we do get a small bit of commission back if you choose to use them. So we'd like to thank you for that. So all that leaves me to say now is thank you guys for watching and I'll see you in the next one.